Good day to you all. I'm Niwunhella. I'm here to present the paper on critical review of the use of Crosshole Sonic Logging method as a tool to investigate the integrity of board and cast in-situ files. Other authors are K.C.Waduge and Professor H.S.Thilakasiri. This is the outline of the presentation. Moving on to the introduction. Board and cast in-situ piles are a widely used type of deep foundation which carry higher design loads on weak or compressible soil layers. It is common that due to the improper construction methodologies, defects can be occurred along the board pile, diminishing its carrying capacity. Therefore, it is important to check the integrity of board piles and apply remedies to ensure the optimum durability and stability of the piles. In the industry, there are several pile integrity testing methods, including the Crosshole Sonic Logging test and thermal integrity profiling method, etc. Crosshole Sonic Logging test is a non-destructive pile integrity testing method which is based on the transmission of an ultrasonic wave through concrete between a transmitter and a receiver. First arrival time and the energy of the received wave are considered for the identification of anomalies of the shaft at a given depth in between the vertically installed parallel access ducts of the pile shaft. The waterfall diagram derived from the above parameters are used to identify the anomalous areas in the pile. Though CSL test reveals the existence of anomalies in the board piles, its standalone capabilities are sufficient to get a comprehensive detail on the identified anomalies. Hence, the severity of the anomalies and its physical properties are further evaluated using the tomography analysis. Tomography is a mathematical simulation which provides a 2D and 3D images of the cross-section of identified anomalies in the pile shaft, model using the wave speed obtained through Crosshole Sonic Logging test. Moving on to the introduction to thermal integrity profiling. TIP is also a standard non-destructive pile integrity testing method based on the generation of heat of concrete during the curing process. It generally measures the temperature at the radial locations of the rebar case with higher gradients. As shown in figure, the relatively low temperature indicate the absence of concrete and vice versa. Also, the measured temperature indicates the alignment of the rebar case and the effective carbon. Moving on to the problem statement. Based on the CSL test and tomography, the overall acceptability of the board piles are assessed using the classification systems used in the industry. Some piles are subjected for unnecessary remedies based on those classifications. Hence, it is vital to evaluate the different classification systems and the effectiveness and the reliability towards the identification of defects in board piles. Also, it is required to assess the contribution of tomography analysis towards the anomaly differentiation. Moreover, special attention should be given to identify the potential reasons for the occurrence of anomalies in board piles. Also, the shortcomings of CSL test should be identified and the adaptability of other integrity tests such as thermal integrity profiling should be evaluated thoroughly. This is the methodology used for the research. First, the CSL test and tomography test reports for a board and cast in-situ files were collected. Then classification systems were identified from the test reports and literature. Then the test results were interpreted by analyzing and classifying the piles into acceptance ranks. Then the integrity of each pile was assessed using the tomography test reports. And the most accurate pile classification systems was identified, and also the impact of the anomaly distribution along the pile shaft towards the pile acceptability was investigated. Next, the contribution of tomography analysis towards the pile acceptance was studied. Then the potential reasons for the occurrence of defects in the pile shaft were identified. Finally, shortcomings of CSL tests were identified and the adaptability of TIP method on overcoming the inherent shortcomings of CSL test in terms of technical and financial aspects under the Sri Lankan context was evaluated. Moving on to the analysis of test results. The pile sample was categorized according to the following universal pile profile categorization scale used in the industry. Piles are categorized from good, questionable, poor flow, and poor defect ratings depending on the first arrival time of the received wave and reduction in the energy of the corresponding pile profiles. Followed by the universal scale, 3 classification systems were identified from the test reports and the industry for the interpretation. This is the classification system 1, and this is the classification system 2, and this is the classification system 3. 25 board and cast in-situ piles were considered for the interpretation. Each pile was classified under all 3 identified classification systems using the outputs of CSL test. Overall acceptability was evaluated using the tomography analysis. This is a summary of the results interpretation. Piles were classified under 3 classification systems with their corresponding rating. Effective areas of the identified anomalous regions were analyzed using the tomography test results. Then overall pile acceptance was determined based on the effective area from the tomography. Hence, the accurate classification systems which predicted the pile acceptability was identified for each pile. This is the rest of the interpretation of pile sample from pile 13 to pile 25. Moving on to the identification of shortcomings in CSL test. A case where a board pile was considered as acceptable below its cutoff level according to CSL test. Only one pile profile at 1.57 meter depth was identified as questionable, but surrounding excavation of the above pile revealed an exposure of rebar cage to the outside, which has a contradiction output with compared to the CSL test. And it shows that CSL test was unable to identify the exposure of rebar cage, but yet the pile has been considered as acceptable. Those type of defects are considered as critical defects. Hence, it verifies that the CSL test is only capable of identifying defects of the area within the rebar cage. This is one of the shortcomings in CSL test. And also moving on to the financial feasibility TIP tests in Sri Lanka. To compare the financial feasibility, both costings for CSL and TIP tests were collected through Pile Dynamics Incorporation. And table 6 shows the cost comparison of CSL and TIP. So it shows that the TIP cost of CIP test is substantially higher compared to the Crosshole Sonic Logging test. And moving on to the discussion. After a comprehensive study, differences of each acceptance levels of all three classification systems are identified as follows. Acceptance level 3 of classification system 1 is based on the distribution behavior of anomalies along the pile shaft, but acceptance level 4 is based on the localization of anomalies in the same cross section. In system 2, the acceptance level 2 and 4 are identical with criterion of classification system 1, but both acceptance level 3 and 4 are considered the localization of anomalies. In system 3, the acceptance level 1 is identical to classification system 2. Both acceptance levels 3 and 4 consider the distributed presence of anomalies along the shaft. It can be identified that classification system 3 is comparably conservative than the other classification system due to the consideration of less percentage of poor defect and poor flow profiles in the acceptable criteria. Table 10 shows the classifier's allocation of pile sample in each classification system. According to table 10, 88% of the piles in the sample with localized presence of anomalies within the same transverse cross sections are determined as unacceptable. And also it can be identified that 64% of piles in samples are considered unacceptable based on the effective areas of the tomography. Following are the percentages of piles in class 3 and 4 which are considered acceptable after tomography analysis. It shows that classification system 3 has a lower percentage of providing inaccurate acceptance criteria. Several piles which are initially considered as unacceptable in classification systems were considered as acceptable based on the effective areas of anomalies from tomography analysis. It reflects the significance of the tomography analysis towards the mitigation of unnecessary further analysis and remedial actions. Figure 6 shows the percentage accuracy of each classification system on predicting pile acceptability. Classification system 3 has a considerable accuracy on this regard due to its conservative approach. It was identified that 80% of the piles in sample had defects in toe region. Possible reason for the soft toe defects are due to improper cleaning prior to the concreting, and the rest 20% had intermediate defects along the pile shaft, which are likely to occur due to the delay in concrete truck, implying poor planning. CSL is only capable of identifying defects in the area within the rebar cage, which is a major shortcoming affecting the pile integrity. Also, the access tubes can be debonded and inclined, impacting the output. Also, the pre-selection of pile should be done to install the access tubes. Those can be considered as the other shortcomings of CSL test. TIP test can be identified as an alternative for CSL test to its shortcomings. Its ability to check the integrity of entire pile section is advantageous. Also, results can be obtained within a short period of time, but TIP is not economically feasible compared to CSL due to high cost. TIP can be used to evaluate the integrity of very crucial piles irrespective of the cost. Moving on to the conclusion, due to the conservative acceptance criterion, classification system 3 has provided more accurate and reliable interpretation of pile acceptance. Also, tomography analysis imposed a major impact on the overall pile acceptance and thus mitigated the unnecessary remedies and further analysis. Localized presence of anomalies in same cross-section enhances the severity of the defect, where distributed presence imposes less impact on the severity. Majority of pile defects in Sri Lanka occurred in Tor region due to improper quality control measures. Intermediate defects are also occurred due to lack of planning. Hence, thorough quality control measures should be maintained during the construction. TIB can be identified as an alternative for CSL, but it's not financially feasible option. However, TIB can be very useful and ideal to evaluate the integrity of most critical and important and sensitive pile shaft in the structures, as integrity of such piles are extremely vital. This is the end of my presentation. Thank you very much.